Here are the answers for the section 13-3 word problems homework assignment. Number 1. How much did an engineer at Fairfield Aircraft earn in 10 years if his starting salary was $6,000 and received an annual increase of $350? From that information, I know that the first term, where the value of A is $6,000, and that the difference each year is $350. I want to find the sum of the salaries for 10 years, or S sub 10. So let's use a formula for that. S sub 10 is equal to 10 divided by 2 times the value of A plus 10 minus 1 times the value of D. Type that expression in the calculator to get the answer. And the result is $75,750. Next, number 3. In the front section of the lecture hall, there are 25 seats in the first row, and there are 2 seats more in each following row. So the first row has 25 seats, the second row has 27 seats, the third row has 29 seats, and so on. The question is, how many seats total are there in the front 10 rows? So we want to find the sum of the first 10 numbers in a sequence that starts with 25 and has a value of 2 for D. Let's use our formula again. S sub n equals 10 divided by 2, and then 2 times the value of A, plus, then 10 minus 1 times the value of D. And then evaluate that expression on a calculator. The result is 340 seats. Next, number 9. John repays the $675 that he owes his brother by making monthly payments. In the first month, he pays $10. I've written that as the first number in a sequence. In the second month, he pays $15. And the third month, $20, and so on. So we have a sequence where the value of D is 5. If he needs to pay off $675 total, that means that we want the sum of the monthly payments to add up to $675. The question asks, how long does it take him to pay off the debt? So we need to find out how many terms there are in the sequence. That'd be finding the answer for n. So let's use our general formula. S sub n equals n divided by 2 times 2 times A plus n minus 1 times D. For S sub n, fill in 675. For the value of A, fill in 10. The letter n is the one we don't know, and for D, fill in 5. Now we want to solve this equation for n. First, we could multiply by 2 on both sides. That makes 1350 is equal to n times, and then inside the bracket is 20 plus 5n minus 5. Next step, let's distribute the n. So 20 times n is 20n, 5n times n is 5n squared, and negative 5 times n is negative 5n. Those n terms can be combined together. We have 1350 is equal to 5n squared plus 15n. Now all numbers will divide by 5, so let's do that. That makes 270 is equal to n squared plus 3n. This is a quadratic equation because of the n squared, so let's get it equal to 0, which would be standard form. N squared plus 3n minus 270 equals to 0. Now we want to solve that, either by factoring or the quadratic formula. I'm going to use factoring. N plus 18 times n minus 15. And that's equal to 0. 18 times 15 is 270, and 18 minus 15 makes 3. Solving each factor, we have n equals negative 18, or we have positive 15. Now, remember what n is representing, the number of terms in a sequence, so getting a negative answer makes no sense. We're going to use the answer 15. It will take him 15 payments to pay off the $675. Number 11 doesn't really have any word problem or anything. It just says, find the sum of the first 25 odd integers. So those would be 1, 3, 5, 7, 9, 11, 13, and so on. That is an arithmetic sequence. The value of A is 1, and the value of D is 2. So we can find that sum with the formula. The sum of 25 numbers will be 25 divided by 2 times 2 times the value of A plus 25 take away 1 times the value of D. And then evaluate that on the calculator. The result is 625. By the way, 625 is equivalent to 25 squared, and 25 was the number of terms we added. So isn't that interesting? But we'll leave that for a future section. Number 13. Anne and Hester are both reading pages of a 1,100-page novel. Anne reads 50 pages every day. So I made a sequence of numbers keeping track of how many pages she read each day. On the first day, 50. On the second day, 50. On the third day, 50. And so on. Hester reads 10 pages the first day, 20 the second day, 30 the third day, and so on. After how many days will they be on the same page? Well, what we know is that the sum of their reading is 1,100 pages. So we probably have to use one of those sum formulas. S sub n is equal to n divided by 2 times 2a plus n minus 1 times d. Let's examine Anne's sequence in relation to this formula. The sum is 1,100 pages, and that's equal to n divided by 2 times 2 times the first number, plus n minus 1 times d. But the value of d for Anne is 0. Next, let's simplify a little bit on the right side of this. 2 times 50 is 100, and 100 times n over 2 is 50n. At this point, I'm going to stop working on this equation. Now I'm going to examine Hester's situation and apply the sum formula for Hester. The sum is 1,100 pages, and that's equal to n divided by 2 times 2 times the first term plus n minus 1 times d. And for Hester, d is 10. Then do some simplifying on the right side. This is n divided by 2 times 20 plus 10n minus 10, which is equal to n over 2 times 10n plus 10. This makes 5n squared plus 5n. 5n squared plus 5n is equal to 1,100. And for Anne, the 1,100 was equal to 50n. Therefore, the 5n squared plus 5n is equal to the 50n. Now let's do some work on this equation. 5n squared minus 45n is equal to 0. Then divide everything by 5. n squared minus 9n is equal to 0. Now we can factor this as n times n minus 9 is equal to 0. n equals 0 or 9. The answer 0 means that after reading for 0 days, the two girls have the same number of pages remaining. They both have 1,100 pages. But the answer of 9 gets at the answer to the question. After 9 days, they will have read the same amount of pages. Next, we're going back to page 499. This was the section about arithmetic means. So we have the number 1 and the number -1, and we're asked to find 5 numbers that go in between there so that we end up with equal spacing in between the numbers. The first number on the list is A, or A sub 1, and the last number is 1, 2, 3, 4, 5, 6, 7, a sub 7. So let's use the formula for the nth term of an arithmetic sequence. A sub n equals a plus n minus 1 times d. And for a sub n, fill in -1. For a, fill in 1. For n, fill in 7. And then times d. Now we can solve for d. Subtract 1 from both sides, we have -2 is equal to 6d, and then divide by 6. So d is equal to -2 over 6, which is -1/3. Start with 1 and subtract 1/3, so that's 2/3. And then subtract 1/3, subtract 1/3, subtract 1/3, and subtract 1/3. When you subtract 1/3 again, you get -3/3, which is -1. Number 13, we want to find the arithmetic mean between these numbers. So we can add them together and divide by 2. You can leave the answer like this, or you might factor out a 3 and write the result like this. Now page 503. We're asked to expand this sum. First, plug in 3 for I. Then 4, then 5, then 6, then 7. There's the expansion. For page 503 on the written exercises, we're asked to actually find the sum. Let's start by expanding it and getting a few of the terms. So first, input 1 for n. 1 plus 1 is 2. 1/2 times 2 makes 1. Now put in 2. 2 plus 1 makes 3. 1/2 of 3 makes 3/2, or 1/2. Now fill in 3. 3 plus 1 makes 4. Half of 4 makes 2. And so on. We could finish the expansion for all 15 terms and then add it up, but it might be faster to use a formula. This is an arithmetic series. A is 1, and D is 1/2, because you're adding 1/2 each time to get to the next answer. So let's find the sum of 15 terms. Put in 15 for n, put in 1 for a, put in 15 for n, and put in 1/2 for d. And then evaluate this answer. The result is 67.5. Next, number 13. We're asked to find the sum of an arithmetic sequence where the first number is 0, the common difference is -1/2, and the last term is -50. We have a formula that involves finding the sum when you know the first and the last term. It looks like this. But we don't know the value of n, and without a number to plug in here, we cannot find the sum. So we need to find the value of m. So let's remember that we have this formula and first figure out n by using the formula a sub n equals a plus n minus 1 times d. For a sub n, let's put in the last term, -50. For a, fill in 0. N is our unknown, and d is -1/2. We have -50 is equal to -1/2 n plus 1/2. When you subtract 1/2 from both sides, we have -50.5 is equal to -1/2 n. Then multiply by -2 on both sides, and n equals 101. There are 101 terms in the series. Now that we know the value of n, we can use our formula to find the sum of the 101 terms. It's 101 divided by 2 times the first term plus the last term. The result is -2,525. Number 17. This time we're asked to write out the first 3 terms, and here's the information we have to work with. So if we want to find the first 3 terms, we have to know the first term, we have to know the value of a, and what we have to work with is s sub n, and l. Well, we have a formula that relates those variables. S sub n equals n divided by 2 times a plus L. For S sub n, put in negative 24. For n, put in 12. We don't know what a is, but for L we can put in 1. Now we can solve for a. This makes negative 24 is equal to 6a plus 6. Subtract 6 from both sides, we have negative 30 is equal to 6a, and then divide by 6, we get a equals negative 5. We know the first number in our sequence is negative 5. We need to find the second one and the third one. Well, to do that, we either need to know the value of d, or we need to know a general formula that will find us any term. Let's use the general term formula for an arithmetic sequence. A sub n equals a plus n minus 1 times d. For a sub n, let's use our last term, which we now know is the 12th term. So I'm going to fill in 1 for a sub n. For a, fill in negative 5. We had just figured that out. For n, fill in 12. And the variable that we don't know is d. So notice we can solve this to get d. Add 5 to both sides, and then divide by 11. So d equals 6 elevenths. Negative 5 add 6 elevenths makes negative 4 and 5 elevenths. Then when you add 6 elevenths to that, it makes negative 3 and 10 elevenths. Here are the first 3 numbers in the sequence. Next, number 27. We're given this series with 5 terms in it. We're asked to write it using the sigma notation. We need to choose a variable for our index. I'm going to pick I. I'm counting from 1 through 5 because there are 5 terms. Then on the side is where you put in the general formula. Well, what kind of a series is this? This is arithmetic. The value of a is 2. And then when you look from term to term, you can figure out that d is negative a half. Let's create the general term for that kind of a sequence. A sub n equals the value of a plus n minus 1 times the value of d. And then simplify on the right side. This is 2 minus 1 half n plus 1 half. This makes negative 1 half n plus 2 1/2. And there's our general term. When I write it here, instead of using n, I'm going to use I to match my index. It's customary when the general term formula has more than one term in it to put that in parentheses next to the sigma symbol.